Hi, I'm Prerana Kumsi, and in this video, I'll walk you through the architecture of Twin Mind Second Brain prototype, um, which serves as a personal second brain. And more importantly, I'll also tell you the key design trade-offs that I made while building it. So let me start with the demo. Let's run the backend. The application startup is complete. We'll also run the Celery worker. Yeah, so once it's ready, I should be able to open my UI. Great. So here I have, sessions. I can create a new session every time I start a new chat, and this is a auto-generated user ID. And in this part, I can ingest a URL, PDF, or an audio file, and I can chat here, and I can also see the activity like the logs displaying here. Cool. So let's get started. Ask a random question. What is yes, AI? Okay, what is AI? Let's take a random URL link, upload it, and the job has been created. Cool. So explain to me the URL in, say, 10 sentences. Okay, it gave me some response. Nice. Let me open a different PDF this time. Okay, Christmas customs. Let's see what this is. What is in this file? Okay, there are some random things. Okay, about customs celebrated in Christmas. Okay, Boxing Day. So, what is Boxing Day? When is it celebrated? Okay, wow, I didn't know this. That's cool. Okay, let's also try the third one, which is uploading an audio. Let's choose a file, upload audio. I have no clue about what's in the audio file. Tell me about. Okay, it's about the English We Speak series or something. Also, a cool thing about this is that it tells us the source about where it's answering from. So it kind of gives us a little bit more confidence. Um, we can, I think, move to the high level architecture. Also, this is, I think, going to help us in understanding the sequence diagram, where as a user you upload an artifact, then there's an API to ingest it. You save the artifact, you have some queues where you're enqueuing the job. From worker, you dequeue it, then you update, you load the data. Meanwhile, the worker also tries to extract the text and the metadata, the timestamp, as well as it chunks and embeds the data, and it updates the job whether it's succeeded or it's failed to Postgres. And yeah, so the artifact is processed into a document. The document is split into smaller chunks, and each chunk is embedded and indexed, allowing semantic search across all kinds of modalities. And at the query time, the system will retrieve the most relevant chunk. And It can also optionally re-rank them. Um, Also, we go back here. We see that the chunk documents into around 600 to 900 tokens. And I have tried to use hybrid retrieval as opposed to dense retrieval. Yes, because the dense embeddings alone will miss identifiers and exact phrases, whereas the hybrid retrieval will improve recall in real memory queries. Um, Also, LLM based re-ranking has been implemented so that no extra infrastructure is used under a very tight timeline. And LLMs can also reason across semantics, time, and also metadata in just one step. So it's kind of easy to iterate on the ranking logic via just prompt updates. As you can see here, this is the Celery worker running. So here we have implemented ingestion in an asynchronous manner so that you can avoid blocking the UI, and also it helps to allow retries and failure recovery. Um, let's see the as I mentioned earlier. Yeah, so I've also chosen Postgres as the system of record to keep the metadata, the time filters, and the vector in one place. Um, so mostly that's about my demo. In summary, this particular project tries to demonstrate an end-to-end multi-model system which helps to emphasize on the retrieval quality, the temporal awareness, as well as the trustworthy AI outputs. Thank you.